Okay, so I wanted to put out a video where I'm just doing a few more Hess's Law problems, first so that you can see them being done, and then so that you can go and practice them yourself. So there is an extra practice worksheet posted onto eLearning where you're given the problem as well as the worked out answer, so you can always check your work. Okay, so I'm going to do 2 of those examples in this video today. And then there's 2 more examples in that worksheet that you can do independently and check your work from there. Again, like we said in class, Hess's Law is very much like solving a system of equations where you're taking multiple equations, in this case chemical reactions, rearranging them so that variables, in this case compounds and elements, cancel out and then come together to solve for one overall reaction. So, our first example has 3 thermochemical equations that we need to use to solve for this equation down here. So, before we start, take a second, pause the video, look at the 3 equations that I have in red, compare them to the equation that I have in blue, and hypothesize, think of a plan of what you think needs to be done to each equation in order to solve for this. So go ahead and pause the video to do that. Okay, so the first thing you want to do is compare the equation that we want to get to with the 3 or 2 or 4, whatever, however many equations we're given. So we want to compare the equation we want to get to with the equations that we have. So what I like to do is to look at all of my products and my reactants in my final equation and find them in all of my thermochemical equations that were given. So C2H4 is right here. H2 is right here, and C2H6 is over there. So we only need 3 of the compounds that are in these equations in order to solve for this problem. That means that we have to cancel out oxygen, CO2, and water in some way in order to do that. So what we should be able to see first is that C2H4 and H2 are currently on the correct side of our arrow. They are both on the reactant side, and in our final equation, we want those to be in the reactants. C2H6, however, is on the reactant side in our thermochemical equation, but it's in the product side of the equation that we want to get to. So that means that our second equation has to be reversed. And remember, when we reverse, our delta H has to change signs. Okay. Now that we know what we have to do in order to put those equations into the correct sides of the arrow, we just want to double check our molar coefficients. First in our reactants and our products of the equation that we want to get, as well as the compounds that we need to cancel out, because if they're not in equal amounts on either side of the arrow, then they won't cancel out. So C2H4 has a molar coefficient of 1 in both the equation and the final equation, as does H2 and as does C2H6. So because all of our molar coefficients are unchanged between our 3 thermochemical equations compared to the equation that we want to get, we do not need to change any of the other compounds in there, because what we do to one, we have to do to all. So the only thing that we have to change in this reaction, or in this set of reactions, is we have to reverse our second equation. So what is that going to look like? Well, we are going to have C2H4 plus 3O2 going to 2CO2 plus 2 H2Os we're going to keep our delta H the same at negative 1411 kilojoules per mole. For our second equation, we have to reverse it, so we're going to have 2 CO2 plus 3 H2O going to C2H6 plus 7 halves O2. Put a 7 there. So our delta H is going to change signs, so it's going to be positive 1560 kilojoules per mole. Again, because we reversed it, our delta H is going to change signs. Our final equation is unchanged, so we have H2 plus 1/2 O2 going to H2O. Okay, and our delta H remains the same at negative 285.8 kilojoules per mole. Okay, so we've done everything to these equations. We want to double check that everything is canceling out as well as keeping our final products and reactants around. So the things that are going to cancel, we said, were oxygen, CO2, and water. So let's look at water. I have 2 waters here, another water there, meaning I have 3 waters on my product side and 3 waters on my reactant side. So they can come from multiple reactions, okay, as long as they add up on either side of all of the arrows. So that means my waters are going to cancel out because they are equal on either side. Let's look at CO2. I have 2 CO2s here and 2 CO2s there. Those are equal on either side and they cancel each other out. Oxygen, we are oftentimes going to see oxygen in halves form, so just keep that in mind when you're doing these equations by yourself. So because of that, I want to change this 3 O2 to 6 halves O2. Okay, so because we have 7 halves O2 and 1/2 here, and 6 halves there. Okay, so we have 6 halves O2, 1/2 O2 on the reactant side, which equals 7 halves O2, which cancels out with the 7 halves O2 on the other side. So we are then left with C2H4, H2, and C2H6 in the correct spots. So we're left with C2H4 plus H2 goes to C2H6, okay? And then we take our delta H's and we're going to add down, okay, making sure we mind our signs appropriately, which is going to give us a delta H of negative 137 kilojoules per mole. So that's our final answer for this problem. Okay, so let's move on to our second example. Now, with this one, it's the same setup where we have 3 equations that we want to solve for, and we have our final equation that we need. So, pause the video again and set up a plan of what you think needs to be done to each of these equations in order to get to our final equation here on the bottom. Okay, let's take a second and highlight where each of our products and reactants of the equation that we want to get to are in our thermochemical equations. So NH3 is right there. O2 is going to be in a couple places. So we have O2 here, O2 there. Lovely. NO, it's going to be right there. And H2O is going to be right there. Okay, so that means that we're going to have to cancel out some N2s and some H2s because those don't end up in our final equation. Now, you'll notice that we are off in some of our coefficients here. So if we look at NH3, our thermochemical equation has a 2 and a 4, plus the NH3 is in the product side in our thermochemical equation, and we need it to be in the reactant side. So this second equation is going to have to be reversed as well as multiplied by 2. Oxygen, since it's coming from either source, the multiplication is likely going to come from the multiplication of either one or both of the equations, depending on the other reactants or products that are either being canceled out or moved around. So just like when we had combustion reactions and balancing combustion reactions, leave oxygen for last. Okay, so NO, nitrous oxide, has a 4 and a 2. So our first equation here, I'm going to try to keep this neat, is going to be multiplied by 2. But since NO2 is on the product side in both of those equations, we don't need to reverse it. Finally, we have 6 H2Os. Okay, so we have 6 here and 2 here, meaning our last equation is going to be multiplied by 3. Now, when we go and do all of these reversing and multiplication portions, we should hopefully see that we get to our 5 O2s when we come out and do our full addition and start canceling out compounds, okay? So because oxygen is present in 2 different equations, we can't set one to be equal to that 5 because the other equation is also going to depend on it. So again, leave oxygen for the very end and worry about all the other variables that are coming from one equation at a time. Okay, so let's get to it. Our first equation, we just said we had to multiply by 2. So we are going to make that 2N2 plus 2O2 goes to 4NO. And our delta H is then going to be doubled. So we're going to get negative 361 kilojoules per mole. Our second equation, we said, needs to be reversed and multiplied by 2. So that's going to give us 4 NH3s going to 2 N2s plus 6 H2s. And then our third equation needed to be multiplied by 3, which gives us 6 H2 plus 3 O2 goes to 6 H2O. Oops, I forgot to do our reversing and multiplying of our second equation. So for our second equation, since we reversed it and then multiplied by 2, our delta H is going to become positive and multiplied by 2. So that'll be positive 183.6 kilojoules per mole. And then delta H for our third equation, we didn't reverse it, but we multiplied it by 3. So that'll give us a delta H of negative 1450.8 kilojoules per mole. Okay, so let's see what cancels out on either side. So we said that N2 and H2 are going to cancel. So I have 2 N2s here and 2 N2s there. I don't have N2 in any other spot, so they cancel out because they're equal on either side. I then have 6 H2s here and 6 H2s there. There's no other place that provides me H2s, so they cancel out. So that's everything that needed to be canceled. We now want to check that our final products and reactants equal out to the equation that we have up here in blue. So we need to find our 4 NH3s. We have our 5 O2s from these 2 equations, so they're going to be 2 O2 plus 3 O2. We have our 4 NOs and our 6 H2Os. Okay, and those are on the correct sides of every equation, giving us 4NH3 plus 5O2 going to 4NO plus 6H2O. Okay, and that's exactly what we had up here in blue. So our delta H, we're now just going to multiply. Why do I keep saying that? We're going to add. We're going to add down our 3 delta H's, making sure that we keep the signs as they are, as we have shown. And that will give us a final delta H of negative 1628 kilojoules per mole. Okay, so that's 2 of the examples from the worksheet that is posted on eLearning. I encourage you to go to the other 2 examples and look at them in the same way that we did here, where you first look at each equation, predict what you think needs to be done to each equation in order to achieve the final equation. Do those steps, double check that everything cancels out, double check that your final reactants and products are still present and in the correct molar amounts. Add up your delta H's with the appropriate signs, and then you've solved the problem. Once you've done that for each of the 2 examples that are left in the worksheet posted on eLearning, then you can check your answers with the answer key that was also provided.